Hello, everyone. Welcome to the first computer science seminar of the 2023 year. We are pleased to welcome Dr. Luther Tychonievich, who is coming to us from the University of Illinois, Urbana-Champaign. And he's going to be talking to us about some of his work in helping redevelop the curriculum of the University of Virginia, some work he did with actually a very large team out there looking at how do they reformat their curriculum for modern times. And that's something that we're actually looking at doing with our own curriculum here in the very near future. And we thought inviting him down to give us a talk on what challenges and what unexpected lessons they learned from that might be a really good way of kicking that off. He is also a member of ACM, the Special Interest Group in Computer Science Education. He's obviously a computer science researcher of some note and also a very good teacher. So we're very happy to have him. I'd like you guys to extend a warm welcome, and I'll turn it over to Luther.
Thank you. All right. Thank you. So, as mentioned, I'm Luther Tychonievich. I'm going to be talking about what I did at University of Virginia, where I worked for 9 years, starting in 2013. Primarily, I worked with Mark Sheriff there, but as you'll see, many people got involved. So let's, I have here a reference to a paper we published last year about this. I'm not really going to follow the paper. The paper was in what we call an experience report track. So it describes what we did in some detail, the curriculum we had before, the curriculum we had after. I'm going to try to draw more on big pictures and things to think about as we're going through this. So here is my outline, some questions we're going to try to answer. What is a curriculum? Why do they need to be changed? Can the changes happen one course at a time? How do we design that kind of overhaul if they can't happen one at a time? We'll talk a little about keeping people happy in the middle. Then we'll talk about how to roll out the change and try to decide if what we did for a decade was worth doing. So let's dive in. What's a curriculum? When I say a curriculum, what do you think I mean? Turns out this is an overload term as many others are. So let's say the curriculum of an entire degree program, not a single course. You're sort of spread out, but I'm still going to pretend like you're going to talk to each other anyway. Find somebody else and try to define this term to them. What is a curriculum of an entire degree program? What is that? You should be talking. This may mean you get up and move. Be upstanding, find somebody else and talk. All right, well, if this were my class, I would now call on somebody that didn't talk to somebody else to tell us the definition. But since you're never going to see me again, there's no need to get you to hate me right away. So instead, I'll just share a definition I'm going to use in this talk. A curriculum is a set of courses. This, of course, begs the question, what's a course? I think we all have an intuitive understanding of what a course is because we've been in several. But I'm going to define a course as follows. A course is intended to produce certain student attributes. Okay, now typically there's a modality in them and so on, but the goal is to produce these attributes. What do I mean by attributes? There are three that we often talk about. First, knowledge. I might have a course where I want you to know what big O means. For example, okay, know how it's defined, know big O notation. I might also want you to understand what it means so that when I say big O in log n, you know what I mean. What does that say? What does that not say? I might also want you to have the ability to find the big O of something, okay? Sometimes also called skill instead. And this is often how we think about the things courses produce. Knowledge, understanding, and ability. Now, as we were thinking about our curriculum, we started asking faculty to complain about the courses before theirs. So when you ask a faculty member, hey, the courses that are prerequisites to yours, what are they not teaching students? They usually didn't identify these kinds of things. They didn't have a clear way of describing it, but when you talk to them, you realize they are talking something along the lines of an attitude. So a course that teaches Big O should teach you what it is and how it works and so on, but it should also teach you to start there. You should have an attitude of asymptotics is an appropriate approach to something. And this attitude turned out to be more important often to the teachers of later courses than the skills and understandings and knowledge that was there. And then even more than this, what they really wanted was perspective. They didn't just want you to know what Big O was. They wanted you to have seen so many different Big O's for so many algorithms that when I introduce a new algorithm and say it's n squared log n, you know whether to say, oh, well, that's good, or oh, right? We want you to have a reaction to what we say based on this perspective you have received. And there's lots of these kinds of perspectives that were necessary, and they usually weren't specified. When you asked a teacher, what does your course teach? They almost never said it teaches an attitude, right? And yet that attitude was an important part of how our courses fit together. So these are things that courses are intended to produce, but you notice I have an asterisk next to produce. Because it turns out that they tend to also select for some of these attributes without producing them. Okay? It's much easier to make a course you can't pass unless you have some attribute than to make a course that provides that attribute. It's easier to test for many of these in some fashion than it is to produce them. And so we usually had courses that the outcome were students with certain attributes, some of which were developed and some of which weren't. And there was some sort of accidental weed out behavior going on in some of our courses as well. So this is what curriculum is, a set of courses where courses produce these things. Now, how do you produce them? To make a course produce these, you need to assume certain attributes coming in. If I don't have the attributes coming in, you can't benefit from what I am doing. If I want to teach Big O, assuming you know how to program and you don't know how to program, then things are going to go bad. If I'm going to teach in English and you don't speak English, then we're going to have some trouble, right? There's various things I need to assume coming in. But it turns out these are very hard to guarantee. Although I can make a course that you're likely to fail without an attribute, I can't make it perfect. And I don't really know if every student that passes a course has an attribute. For example, most programs let you pass a course with 70% of the material. If my course needed the 30% you didn't get, then we're in trouble, right? If you have 70% of the 30% I need, right, then we're less trouble. If you have all of it. So just knowing that you passed a course doesn't really tell me if you have the attributes. But we can't really enforce the attributes, so we enforce courses instead. And because we enforce courses, we end up with a directed graph of courses. Courses are nodes, and then sort of these implicit attributes are the connections, the prerequisite relationships between them. So for example, this is the dependency graph we had for our curriculum before we started revising it. Okay, you do not need to understand the details of it. I will talk briefly about its complexity though. You'll notice that I have different colored borders. Some have round borders, some have thick borders, some have thin borders, some have no borders. I have some dark colors, some light. There's all kinds of other things we were trying to communicate with this graph when we created it, to be like what degree programs need what and so on. But let's zoom in and think a little about some of these arrows. I'm going to zoom in on part of these and talk about some specific attributes that we were able to identify. These are not all the attributes, but discrete mathematics was a prerequisite for our program and data representation course. And as we talked to the program data representation faculty, we discovered they wanted to know the knowledge of sets and integers, how they work, what they are. The skill of converting between math and English was important for this course. They also want just the attitude that math is useful. The teacher wanted to be able to say, we have an algorithm, we're going to analyze it with math, and they want the students to have a positive instead of negative reaction, right? Which was this attitude they hoped would be developed. Arguably wasn't developed, that's a side note. Anyway, continuing on, if we think about another one of these relationships, there was an understanding of binary representations, not just a knowledge of what 2's complement was, but really how it works, that was necessary for our computer architecture. And wanted a skill, a lot of skills actually in this particular relationship. One of them was the skill of navigating the Linux command line. It was important for the way this course was taught. It wasn't intrinsic to the course, but it was something the way it was taught needed. And they also wanted this perspective from many examples of taking complicated things and breaking them into smaller pieces until they made sense and then working your way back out. You want to have that perspective that could be done because they want to use it without recalibrating to this. So these are some examples of some of the attributes we found for our courses. Now, can you find all of the rest of the attributes written down in some nice document somewhere? No. We discovered after many, many tries, that maintaining a full specification of these attribute relationships between courses was just harder than its perceived utility justifies. It is a lot of work to identify what perspectives and attitudes and so on every course depends on for every other. We tried many times. And we got okay versions, but we would always find things that didn't work. It was just hard to write these documents. By the time they got complete, they were too long for anybody to read and therefore useless, right? And so you end up instead with this sort of intuitive understanding. You hope you understand correctly what the attributes provided by the other courses are, because they're only in vague notions in your head. And some sub-parts of them are written down. It's a sort of loosey-goosey, we hope it works kind of experience of having our courses fit together. So that's what we mean by a curriculum. Given we have a curriculum, somebody went to all the effort to build this thing, many people taught it, many people took it, why would we change it? Why do you change your curriculum? I was introduced by mentioning you're thinking about changing your curriculum. I assume some people in this room aren't thinking about it, but some are. Why? Why would you change your curriculum? I'm going through a lot of reasons. Okay, let's start with the first one. The field advances. Okay, new stuff is discovered and old stuff doesn't stop being true. It is a monotonic increase of information. New information comes in, old information never expires. But I have to get rid of old stuff to make room for the new stuff. I can't, every time there's a new discovery, just add a new course, because then students have to be in the program for forever. So we always have to figure out something that's still true, but no longer as important, as relevant, and cut its amount, or sometimes cut its coverage entirely, to make room for something I now deem is more important. Let me give an example we faced. UVA had a very strong sort of systems design and security group. And while we were redesigning our program, this new set of security exploits called Spectre and Meltdown came along. And these depend on very nuanced understanding of modern processors, out-of-order execution and speculative execution and reorder buffers and advanced caching techniques, which up to that point had been true, but had been put in some sort of like graduate level elective. But suddenly our security and systems faculty said, no, these are really important. You have to make them required. And we said, well, it's going to take us weeks and weeks and weeks to teach it. We know we've been doing it in senior electives. How do we do this? They said, well, here's all this stuff we used to say was important, but it's not as important. It all needs to go to make room for something new. Okay? So this sort of thing happens all the time. Usually happens internally to a single course. Okay? There's also advances in pedagogy. Pedagogy meaning how we teach something. We are getting better at knowing how to teach as a community. That doesn't necessarily mean your individual courses are getting better. If you're a student, you may understand that they aren't all getting better. But anyway, in general, they're getting better. This turns out to have an impact on your curriculum. It changes first the side effects caused by what you're teaching. So when I'm teaching something, I usually need to compare it to something else. I usually need an example. I usually need some sort of experience of looking at a particular example of how this works and talking through it. And I might change those examples to ones that work better. But that means later courses can't assume you already know the old examples, right? It's a simple version of this. But there's more profound ones. Broadly speaking, bad pedagogy. If I teach something poorly, then I select for students that will deal with bad teaching. I select for students that will stick with a bad program. I select for students with coping skills broadly. I don't train them in coping skills. I don't make them better at coping. Arguably, actually the opposite. Giving people a lot of hardship makes them worse at coping in general. But I'm selecting for people with a lot of that. And that means that my later courses can also be taught poorly at a first order, right? Because by the time they get to the later courses, they're already used to bad teaching. And as the teaching of the early courses gets better, then the teaching of the later courses has to change, but sometimes there's other impacts. There are some parts of teaching that are just painful. It takes a long, as your programs get bigger, as your bugs get harder to debug, there's some amount of sticking to it that's important. And so the time you have to spend when you get to those topics can change, changing the amount of time you have left for other topics. So you have multiple instances where improved pedagogy in some course was changing the amount of time other topics took in other courses. There's also changes in your stakeholders and who wants your courses. So when some new degree program decides we want a course in programming, that's going to change both the attributes they actually meant they needed out of that and the amount of time they wanted to devote out of their students' curricula to get that. And so you end up with we kept getting more and more clients coming on at UVA. We ended up with almost 30 different courses and degree programs that required a CS class somewhere along the way. And each of them had their own requirements about what they wanted to cover. The biggest of these, we had long had a Bachelor of Science in Computer Science. We had a Bachelor of Arts in Computer Science that was housed in a different college. The different college required fewer overall credits. And so we just had to remove 9 credits of classes from our degree program. And when we talked about it, we decided there was a 3-course sequence and we wanted to remove the first and third course, but keep the second. This obviously had some ripple effects on what we covered in these courses because the prereq was going and so on. There's also changes in our prereqs, the prereqs we require taught by other fields. The biggest of these we encountered actually came from what high school was teaching. Okay, so high schools change without consulting colleges, which probably is correct. But one of the big changes we found 30 years ago, we found that every high school in Virginia taught logarithms in the core. It was a required part of your algebra class. Every student that got to university knew what a logarithm was, knew log identities. Today in Virginia, none of the high schools do. And we found one high school that offered it as an advanced elective if you really love math, right? And so we use logarithms in CS. And we don't even know when it happened. Like we have documentation was there 30 years ago and isn't now. And we don't know when in that time it vanished. But at some point it did. And that meant we had to either start teaching it or start using it less, right? So these sorts of things happen to the degree as well. And then finally, this may not be as obvious, but student interests change. Students come in with some idea in their head as to why they're there and what the field contains. In general, this is an underinformed opinion, right? You come in thinking what a field is about, not yet knowing the field. This is true of all fields. So where did you get that opinion? You got it from random snippets of conversation and from how it showed up in a television show and so on. And that perspective is a little wrong, but it changes what you're interested in. And what you're interested in, you pay more attention to, and what you pay more attention to, you learn more quickly. And so as student interests change, the stuff we have to teach because it's a prereq to whatever it is they're interested in, some of it is now interesting to them and some of it isn't. And so the amount of time you spend on everything changes as well. All of these forces mean you have to change your curriculum. All right, so we've got a curriculum, we have to change it. Can we change it one course at a time? Why would I want to change it one course at a time? Before I talk about can I, why would this be better? Why would I prefer to change one course at a time than many at once? It's easier. If it goes bad, you can easily back it out. It's the same reason we want to change code a few lines at a time instead of rewriting the whole thing, right? For all the same reasons. There's less work to do. There's less chance of messing it up. I don't have to get fewer people to agree, right? So we want to change things one at a time. Can we? Well, usually, yes. The requirements make this work is that I can't require any information, any student attributes that aren't provided by my prereq courses. And I can't stop producing something that my post-req courses need. Because if I stop producing what my post-req courses need, then I break the post-req courses. If I start requiring something that isn't produced, then my students will struggle in my class. But if I can stick within these bounds, I can do anything I want, broadly speaking. And so just about all faculty will do this just about all the time. Most faculty are tweaking their course most semesters, trying to make it better, trying to adapt to the field, trying to adapt to new pedagogy, trying to adapt to their understanding of student interests. The problem here is that these conditions are not enforced at all. The only thing that keeps me from requiring something students don't have is my own perception about what students have, right? The only thing that requires me to keep producing what the next course needs is my own understanding about what the next course thinks is important. And so those are not generally enforced. There's also some changes that need several courses. Sometimes I take a pair of courses and I agree to move content between them. When I do this, it's a bit more complicated. It's a bit more complicated because I need a lag, right? If CS1 changes what it teaches, CS2 can't assume the new content for a couple of semesters. Because there's going to be some students that took CS1 and then took a semester abroad or did some other gap and then want to come back. So we need this little bit of lag in what we do. At UVA, we did do this. We made a very big change to our CS1 and CS2. We actually removed half of the content of CS1, just cut it out completely, to spend twice as much time on the other half, to give a deeper foundation of the other half. And CS2 agreed to cover all of that material we cut. Okay. Now CS2 cut some projects that nobody was using and agreed to go a little faster over some other things. We made this change with just these 2 courses, took us 3 semesters to sort of roll through the transition, but it worked very well. We could do much bigger changes that way and changes in emphasis and coverage that we couldn't do 1 course at a time, because you couldn't cut that much material unless it went somewhere, so you found somewhere for it to go. However, these single and few course changes create another reason for change. Maintaining your courses, making them better, also means I'm going to eventually have to change the curriculum. And the reason why I'm going to borrow a term from software engineering: brittleness. Software engineering, we talk about the idea that maintaining software makes it brittle, makes it harder to maintain and modify in the future. Here is my version for curricula. The maintenance of courses, individually or in small subsets, reduces the fit between courses and the accuracy of the faculty beliefs about the courses surrounding theirs. Okay? And I don't believe this is avoidable. It's just each course is moving, and as each course moves, they stop fitting together like a beautifully designed puzzle. Right? And they fit less well, and there's topics that the faculty all think are being taught, but eventually been removed from the curriculum entirely and nobody noticed. And there's topics that the students realize they've had the exact same lesson on in 5 classes, because they don't all realize that this is happening, right? And the courses just sort of drift apart, individually getting better, but collectively getting worse. Because of this, although usually we can maintain courses individually or in small pairs, small groups, eventually we need to refactor across course boundaries. Cover the same material, but in a different set of courses. We need to rebalance the content between courses. Some courses will get harder, and some courses will get easier as the natural flow of topics, as each of them individually improves while keeping its boundaries fixed. And so we don't really want a super hard course and a super easy course. That's not good for anybody. We need to rebalance that difficulty. We need to resync, get everybody back on the same page about what those prereq relationships actually are. Sometimes you have to redefine what's required versus elective. Maybe it was elective 10 years ago, but it's become more important and it should now be required, or vice versa. And so as a result, there's a periodic need to overhaul your curriculum, to start from scratch, rebuild it from the ground up. This is my thesis. Now, I'm going to dive into how we did this, but before we did that, thoughts, comments, questions about the thesis, about what curriculum is, how we're going to talk about it, anything you'd like to discuss at this point before we dive into the second half of the talk? Okay. How can we design a curriculum overhaul? Well, I don't know. There are precious few examples I could find of people documenting doing this. I found a few from the early 90s, and I found ours. And anecdotally, I know of a few others, but all I know is one. So I'm going to tell you about one. And I'm going to overgeneralize, and I might get it wrong. So just bear that in mind. So let me ask this modified question. How did UVA CS change its curriculum? I'm going to give you first a timeline, and we'll talk some more about what's going on. So as we're going through here, in 2004, after the Computer Science Educators Conference, SIGC at 2004, I was sitting down at a table with 2 other faculty members, and we literally just on a sheet of paper sketched out what we thought would be a better curriculum than what we had then. We all had our vague ideas. We wrote something down. We said, this looks better. But that wasn't the end, right? I was new. I had only been faculty member for about 7 months at this point. And I had this naive expectation that since myself and 2 other faculty all agreed that this would be better, that we would sort of spec it up over the summer, hand it out to everybody. Within a year, we'd be changed. Anyway, we then spent 3 years in what software engineering calls requirement solicitation, trying to figure out what we needed. What do we do during this time? The IEEE and ACM have curricular guidelines they produce roughly every 10 to 20 years, closer to 10 recently. And we went through that. It's a like 500-page document. We went through every page, looked at every single topic it said we should cover at what time, and we found out how much we were covering it. This was hard. Okay? When it says you will have 2 hours on this topic, and you go say, which course covers that? Anyway, there's quite a bit of sleuthing going on, but we went through all of that, came up with how we differed from the recommendation, presented that to the faculty and said, do you care? It says we should cover 3 times as much functional programming as we do. Do you care? And our faculty said, yes, we care. We said, it says you should cover half as much architecture as we do. Do you care? And the faculty said, no, we don't. Right? And that was important information. Okay? We also talked to our current students. The main way we did this, we had a course that every undergraduate teaching assistant had to take their first semester. We had a lot of undergraduate teaching assistants. About 100 students took this every semester. So we had about 100 new undergraduate teaching assistants a semester. We just take a section of that class, and we would say, here's our current curriculum. Rewrite it from scratch. There's no limits. Just pick out whatever you want to do. And they would write down all their new curricula and talk about them, and we'd collect them. We had hundreds and hundreds of these revised curriculum we collected over the years, what they thought should change. We interviewed each and every faculty member individually. Our curriculum committee went out and sent a member of the curriculum committee to every faculty member's office and said, tell us what you think. Okay, we collected a lot of information. Broadly speaking, we learned from this that we can't make everybody happy. What the faculty wanted individually, the union of that was more time than we had. Right? And there's other things we learned as well about specific courses that had problems and specific areas we wanted to go. We also had to think about our degree programs. What does every degree program need? There are sometimes requirements for accreditation or other reasons. We had to figure out what all those were. This meant visiting lots of other departments because, again, we had many departments requiring some of our classes, and we needed to make sure that whatever we changed wouldn't break that. We didn't want to make enemies of other departments. Once we had our requirements sort of more or less solidified, then we started designing our courses. Okay? We had some tentative designs we had made along the way as part of coming up with the requirements, but we didn't really have it fully fleshed out. What topics go in what courses in what sequence? You need to know this to have a curriculum. So how do we do this? It's a lot of work. So we broke all the topics into a few broad areas. There was an area, for example, in systems programming and computer architecture, computer organization, and security. That was all one area. We assigned an area lead that would design the breakdown of topics and courses. They started with the requirements we had collected, wrote a draft of courses, and called an open committee. Any faculty member that wanted could attend, as well as students, although none did, it turned out. And we said, here's what we're thinking. What do you think? And they would say, you're missing something the area lead had never heard of before, and you would go back and redesign, okay? And they would collect this input, and we get it and redesign several times along the way. We also, so we had to define the specific topics that meet the requirements, right? To come out with an actual breakdown of, we will teach the Floyd-Warshall algorithm or not, right? You had to decide at that level so you actually knew what a course contained. Divide it into courses, make sure it met all the requirements. There's also important need to sync. We had these area leads, but if one area started coming up with content that didn't line up with another, they had to get together. So the area leads had to meet often and sync up with one another. And we often went back to the full faculty for comments and suggestions along the way, in which we learned all kinds of things about how they fit or how they didn't fit, and kept changing our curriculum during this 2-year design period. Many repetitions, many iterations, until we had a stable design for our courses. Then we piloted our courses. I'll talk about this later. We spent a couple of years piloting the courses, running dry runs to see if they actually worked. And then we actually rolled them out, which takes several years. I'll talk some more about these later. But this is our process, right? Yes. Yeah, I tried to find that 2014 piece of paper we wrote, and I couldn't, so I'm not 100% sure, but here's what I remember. Basically, each of the we had 3 faculty sitting around a table, and each of us had taught 2 or 3 classes, and we each basically had senses of the weirdnesses of the class, right? So for example, our intro teachers, there are 2 of us that had taught intro. and we both had this sense there was just too much content. We weren't getting through stuff. We weren't getting enough depth because we were covering too many things. Our algorithms teacher was sort of discontented by the disconnect between our algorithms and data structures, and felt like there's a lot of reteaching because they didn't sync well. Right? There's these vague senses of coupled with effectively this idea of wouldn't it be cool if, and this mostly sort of a new structure of how the curriculum fit. Most of what we had back then is at most vaguely echoed in what we finally built. We were right roughly about problems, although we had a small subset of them, but we were wrong on the biggest picture about solutions, or we didn't think of the solution we actually had. Does this answer your question? Okay. No, I don't have a graph of all the inputs because we weren't, when we started doing this, we didn't realize it would take a decade and didn't realize we'd be publishing it. We thought we were just fixing something. And by the time we realized we were deeply underway, right, I start having good documenting about 2016. Some of what we did in 2015 is pretty well documented. But a lot of that rest is my memory and the memory of the other people, which the way memory works don't always agree with each other, even if we were in the same meeting. So sorry, I can't give you super specifics. Yeah. We did. Yes, sorry. I failed to mention there were other people we talked to. So we have a very robust industrial advisory board, about 20 different companies that visit with us. And we asked them a lot about what they thought about our curriculum. Every year we had a day-long meeting with them, and we'd have a session there where we talked about our curriculum and what we're thinking of changing. And we had surprising results. We found, for example, that one of our companies, the person that represented it, knew which faculty member they wanted students to have particular courses from. And if they had this faculty member, they needed an A, but if they had that faculty member, a C was fine, and all, very detailed knowledge of our curriculum. But when we said, what should we teach? Their general comment was, you teach them CS and we'll teach them the particular tools they need to know. And that was basically the level of input they gave us. Every once in a while, there's some very specific topic they would say, yes, or we care about that, but pretty unusual to get much substantive feedback from them. Although they were always very excited to get back in the I'm in school world and play around with the curriculum. Other comments while we're taking comments? Okay. I think I mentioned this a little as we went. Many things changed. Okay? There were surprises, there were changes. For example, one time we asked our TAs, what do you think of our curriculum? And we noticed a pattern was they would pick one of our courses and just say, remove that course. It was CS2, just get rid of it. I'm like, what do you mean get rid of it? Where does all of its content go? And they said, there is no content. And we said, we're pretty sure there's content. Anyway, we learned surprises, and it turned out there was content. There was a perception problem, and anyway, we learned all kinds of things along the way. We learned about different faculties' grading styles. Now, some would give a GPA like 1.5 GPA points below other people in the same course. Just all kinds of things we discovered along the way, not all of which were actually related to curriculum. But when you look closely at curriculum, you uncover all kinds of weirdness because of breaking apart the individual faculty's personal fiefdoms of their course. Okay, I'll make a little aside. That's a long timeline I gave there. Part of the reason is a long timeline is we were really committed to making everybody happy. Okay, so let me ask this question, which is harder? To design a better curriculum than you have now, or to convince people that it's better? We're actually going to just take a quick straw poll show of hands. Which one's harder, A or B? Take a moment to think about it. I think A is harder. I think B is harder. There's a mix, but more people think B is harder. I partly set you up to have that reaction. Sorry about that, manipulating my audience. Anyway, but they're both non-trivial, okay? And we were really committed to B because when we started this, we had at most vague buy-in from leadership. Also, our department culture was very much consensus driven. There was very few things our department did by leadership fiat. It was almost all get consensus before doing it. So we really wanted people to be happy. How do you make people happy? Well, I can't answer this question in every context. If I could have a whole business as a marriage counselor. But broadly speaking, people are happy when nothing seems rushed. Okay? Nobody likes to feel like they're being pressured to make a decision before they're ready to think about it. So we had to expose ideas to people multiple times before asking them to commit. They needed to have the sense of it's ongoing. Everything had to seem well thought out. It turned out it didn't actually matter if it was well thought out. It just had to seem that way. So there'd be a perception of rationale behind it. Now, in general, I think we thought things out pretty well. But we weren't always, at first especially, good at explaining our thought process in a way that made sense to others. So we had to really expose that thinking. And a key part of this is everybody wants to be heard. And you can't be heard in general in a meeting. Which meant we had to visit with every individual by themselves and talk to them. Many of them, many times. And find out what they thought and work through things. Okay? All of that means slower is better. Now, there's of course a desire to make things happen quickly, and we had that too. We didn't want to take forever, right? But we just needed to slow down. It takes time. New ideas take time to settle. If I introduce an idea in the same meeting I ask people to vote on if it's good or bad, they'll be worried. They'll be nervous. But if I introduce it in a meeting and then say we'll talk about this again later, and then a month later I introduce it again, and then a week after that I ask for a vote, then people are like, I got it. I know what you're talking about. So there's some amount of staging and slowing things down so that people had time for the ideas to settle. And the bigger the idea is, the longer it took. There was some benefit in us talking about a curriculum design for a decade. Because by the end of that, it was like, oh, we're talking about this again? We also had to be aware of expert blind spot. When we would come to the faculty presenting something, Mark and I had been thinking about it for hundreds of hours. We had been reading all of the contents about all of our courses. We had been talking to faculty. We had this huge amount of knowledge. And we didn't know what it was that we were automating subconsciously and missing. And so we'd explain something and people would be confused, and we'd be confused why they were confused, because they were confused about something we weren't even thinking about. And we had to slow down, take more steps, explain more things. This also helped us learn more from the faculty, because often their concerns that would catch us by surprise were actually based on something we had sort of overlooked early on and forgotten we had overlooked. In general, if you're presenting something to a group of people, you'd much rather them say, why hasn't this happened yet, instead of, you're doing what? And we got both of these reactions at times. But the why aren't you doing it yet, why hasn't this happened yet, turned out to be a much more important response. That was the response we wanted. We wanted everybody to always think, obviously this is the right thing, just go ahead and do it. And if we lost that sense, then we were going too fast and somebody was generally unhappy. The other thing to understand here is this is about compromise. Okay? We have an over-constrained problem. The union of things faculty individually thought was essential was more than we were teaching in all of our required and elective courses combined. We could not satisfy all of them. It was impossible. But nobody likes to be told that your idea is the one that got the cutting block, right? And so we really had to help them understand that it was over-constrained. Once they understood that it was over-constrained, once they bought into the fact we couldn't do everything, then they are much more open to the idea of some of it isn't going to make the cut. The other thing we had to have is a well thought out, what is our cut? It couldn't feel like playing favoritism. We had to be able to define what the cut was. For us, the cut was things that at least 2 other courses need as a prereq. That was our magical cut that we could use as the rubric. It isn't the only one you could use, but people could understand that. People could decide, yes, you're right, this is important, but it isn't needed by 2 other courses, and we could move forward accordingly. Here is my golden rule about keeping particularly faculty committees happy. Never reject an idea unless you can explain to the idea proposer's idea that it's a good idea and they'll be happy. Okay? So somebody says, here's something that happened. Some faculty member said, you should have 9 credit courses, not 3 credit courses. And we're like, what? Why? How? No. Right? That was our initial reaction. But then we talked to the faculty member that suggested this, walked through it, understood why they believed 9 credit courses would be better, and they went back to the faculty meeting and said, We had a proposal for 9-credit courses. Here are all the reasons that's a great idea. And now here are the reasons we can't do it. And that made the person that suggested it happy. It made all the faculty understood. We listened to them. It made this sense of happiness we wouldn't have had if we'd simply dismissed it as something the university won't let us do. And it was something the university wouldn't let us do. We knew we couldn't do it from the moment they told us. But going through the process helped build a greater sense of camaraderie and happiness amongst the audience. That's how you build happiness, but who should be happy? Well, your faculty. The faculty, generally speaking, own the curriculum. And if they're not happy, things go poorly. That's mostly what my previous slide was about, but they're not the only people. How about students? It turns out you have to think about students in several groups. When we started doing this, the students that were going to be on the new plan, we found it easy to make them happy. We said, we have a new updated curriculum that's fixing problems. Like, yes! Nobody was upset about that. What about all the students that were on the old plan? They were really upset. When we first said we're changing our curriculum and it will start next semester, like, what? I'm already on the old curriculum. I want the new curriculum. They were really upset. So we had to find a way of saying, okay, the reason this is better is we moved topics from one set of courses to another set of courses so that we could make future changes easier. That wasn't the only thing we were doing, but it was a big part of what we were doing. And we weren't shortchanging the students on the older curriculum. They were learning all the stuff they needed to learn. They weren't necessarily learning it in the most optimal way, but they were learning it. And it would be better for them to finish learning it the way they were learning it than try to switch halfway through to a different system. Explaining that effectively was a difficult thing to do. I mean, we got it wrong at first, but we figured it out as we went. There's also another group that mattered to us, although it may not matter to every program. Students declared the CS major, could declare it pretty late in our curriculum. And so we really had a strong desire to allow students to discover that CS is cool after they are at the university and then still complete our degree program appropriately. And this turned out to be a constraint really on the design of our courses, but it was a constraint that was important to think about. And important to think about how we communicate it to the students that arrive on day one wanting to be able to do everything in a 2 years and graduate or whatever it was, to understand that there are multiple clients here that we're thinking about. Administration also matters. If you're a student, hopefully you're blissfully unaware of how much administration does. But administration matters. Basically, administration is used to being undervalued and let on things too late. Most faculty treat most administration as if they're primarily an obstacle making bad decisions. This annoys the administration, as you might imagine, because they see their job as trying to make the university run. And basically, if we just told them early, then they were happy. I remember the first time we visited with the administration and said, talked about all the things we have to do for our new curriculum. And they said, okay, I think we can do this in time. And we said, but this is happening next year, not next month. And they said, what? You're telling us a year in advance? And they were so stunned and so happy with us. Anyway, staff, all the secretaries and advisors and so on, are used to not just being undervalued, but ignored. And the last to know things, they're used to generally, we found many of the staff were used to being told things by students complaining about them, not by faculty implementing them. And we also found the new answers to questions we didn't know to ask. We invited some of our staff to just sit in on our curriculum planning meetings. Sure, they were not trained in computer science. They didn't know the specific topics we were discussing, but they did know what are the assignments students are worried about. When students are stressed, what are they stressed about? They knew things we didn't even know to ask that helped us understand their curriculum more fully. There's also other schools, transfer agreements. Most states have transfer agreements where if you get an associate's degree in a community college, you're guaranteed admission into the university. How do you handle that? Turns out you have to talk to them. You have to tell them, hey, guess what? We're changing our curriculum. No, we aren't asking your input. We're just telling you what's going on, but at least we're telling you, right? I suppose we could have asked their input. We just didn't think about it in time. We have multiple study abroad programs with agreed courses that would matriculate as our courses if you took them at these other universities. We have branch campuses that had similar curricula. All of these people needed to be brought in the loop. We were mostly used to acting like they didn't exist. That turned out not to be a good thing to do in revising our curriculum. There are also plenty of degree programs that required our courses. We actually downloaded the entire course catalog and ran a script to try to figure out how many of them there were, and found just about 30 that had somehow a CS course in their either recommended or required curriculum. And we went out to visit each one of them and said, nursing, we noticed you recommend CS1. Can you tell us why? And then they told us why. I'm like, oh, that makes sense. We should make sure we keep that, right? And so there's a fair amount of this that needed to happen, and they were happy to be informed. They were happy to be asked, but they were even more than happy to be told what was happening in the future. So, how do you roll out a change? I'll tell you again how we rolled out our change. We piloted our courses, made small versions of the new curriculum and offered them first. We learned a lot about the timing and fit. There were things we thought would take 3 weeks that only took 1 week, and vice versa, which we didn't know. It was as we reorganized things, the amount of preparation students had for them was different than we expected. And that made us move things around a little bit between the courses. It also gave us a chance to train TAs before rolling it out to the whole curriculum. So we had these small groups, we overstaffed them with TAs. We'd have some TAs that were ready to be TAs of the new courses, had seen them once before they got to the whole group. It's worth noting, though, that pilots imply many special case exceptions. Almost by definition, every student in the pilot was not taking the regular courses, but still expected to graduate. So we had to work through what that means, all of the paperwork of making that happen. Basically, we had to get the administration and staff on board with the idea of a pilot in advance. We had to be able to explain it to students coming into the university and handle the questions of parents that were confused why my child's friend says he's in the new curriculum and he's in the old curriculum. Why did you put my student in the old curriculum, right? We had to get them all on board to handle these kinds of concerns. This is tedious but necessary. You need to have some way of keeping people from jumping halfway because they end up duplicating half the content and not the other half, which meant we had to create brand new course numbers. That was easy for us. We had 4-digit course numbers, plenty to deal with, but it's still something we had to do, of having some way of keeping people from taking a mix and match where you missed the content that had moved. We need a full schedule of the first and last semester each course would be offered. And we had to make this whole, we planned it out 5 years in advance. We said, all right, this course will be last taught this semester, and its replacement course will be first taught this semester, and publish that, make sure every student has it so they can know as they're planning their study abroads and their leaves and so on, when they're going to do things. We, of course, had to have some overlap because there's gap semesters and retakes and other reasons why you couldn't just make the old course vanishes one semester and the new course appears the next. That almost never works. We also needed a designated faculty staff pair to handle the special cases. There are students who, for reasons outside of our control, need to take a 2-year gap. And then they come back with half of the old curriculum and the old courses are no longer offered, and you have to handle that. So we need a faculty member who understood both the old and new curriculum well enough to say, okay, these are the things you can study on your own, jump into this class, it'll probably work. And we also need a staff member to understand all of the weird exceptions that have to enter the student information system to make this okay, and who to talk to make sure nobody complained. So this was rolling out our curriculum. There's, of course, various approvals and forms as well. Our experience was if people were happy and informed in advance, this was all just paperwork. So our department faculty, by the time we got to finally filling out the form, they were like, yes, so was the school, so was the university. Even the State Board of Education was like, yeah, okay, everybody seems happy with it, it must be good. So that worked out pretty well. So that's what we did. Was it worth it? Before we answer if it's worth the cost, we have to decide what it cost. It cost 10 years. Okay, we started this in 2014. We expect to finish in 2024 to have most of the transition happen. During that time, it was the majority service load of 2 faculty throughout that entire period. So Mark, Sheriff, and I, this was our dominant load of the things besides teaching we were doing throughout that entire period. We also had dozens of faculty meetings, many committee meetings. We designed new courses, trained new TAs. There's lots of just simple hours that were put into this. We also estimated, it's hard to get an exact number here, but our advisors estimated roughly an extra staff year of advising, dealing with all of the students confused about issues about the transition. Okay, So we devoted significant resources to make this happen. Could it cost less? Okay, yeah, I think so. I think if we did it again, we could probably do it in 8 years. I'll talk about what those 8 years are in a moment. If we didn't care about keeping people happy, if we could do it just by fiat, I have the power, I declare, this is our new curriculum, I think we'd probably do it in 4. But let me talk about what those 8 years are. If I were doing it again, I would spend a year making sure I knew what the goals were. Likely by the time I thought this talk was interesting, I may have already done that, but there's still something to do about figuring out what you need to change. Make an inventory of your current courses. You think you know what they teach, but you were wrong. Find out what they're really teaching. Where are the topics actually happening? Brainstorm changes. Get multiple ideas of what your new curriculum could look like from faculty, from students. Get the scope of ideas. See what's out there. And then specify the new courses. While you're specifying the new courses, you should also be planning a pilot. I would recommend pilot. I suppose you could skip the pilot, but we found so many things during the pilot, I wouldn't recommend it. And it takes a while to get all of the people that will need to do the pilot on board with the pilot. Then you pilot the courses while planning the transition. I recommend piloting courses again because you found mistakes the first time. We found few enough mistakes. We probably could have piloted just once. We were happy to have piloted a second time though. That also gave us a year to work through all of the approvals. Although everybody was happy, it was just paperwork. It was a lot of paperwork. A lot of paperwork. Our state board of education sent back our forms twice for having the wrong font and things. Anyway, so a lot of paperwork there, and then you roll them out. I put year 8 here because although we haven't finished rolling them out, there's an interesting thing that happens the semester after a course vanishes. And that's when you first find out if you actually have a functioning system for dealing with special cases. The first student that wanted an old course and it isn't there anymore, can you actually handle that? And that's going on right now at UVA, but as I understand, they're finding out it's mostly working, but there were some things they had to tweak. So that's what it could cost, I think. Is it worth it? Our faculty gave a unanimous yes. Happiness achieved. We engineered this result, right? But what in particular were they happy about? There were more time on the most important topics. We had found out what the faculty thought was most important, and we put more time on it. It turned out that some things got a lot more time. That previously got exposure, now got depth. We got to integrate social and ethical issues throughout our curriculum. Each course as we designed it. And we also said, okay, while you're talking about, I don't know, discrete mathematics, what are the social and ethical issues that fit naturally in a discrete mathematics course? And we had lesson plans for them and managed to integrate them in a place that felt natural instead of an aside. We still had side courses on ethics, but we found this also helped make that make more sense. We had a much smoother transfer situation. We had been thinking about our transfer arrangements as we were designing our courses. They fit better with the other courses. We had good specifications of them that the community colleges could use and so on. We had more shared between our different degree programs, so they looked more similar. They were effectively all, they shared the first set of courses and at some point would stop, which made it much easier to teach together. We ended up with a shallower and broader prerequisite graph. So if you wanted to sprint through our courses, you could do it in fewer semesters, which turned out to be useful for a variety of purposes, of people discovering late, people having other reasons they need to do things quickly. We had updated content. Overall, about 20% change in our content, although some courses is more than 50%. These are fuzzy numbers. It's hard to say how much is a percent of content, but roughly most courses suggested they were having something around this range. Of course, they move between courses a lot, but overall, there are many things we are teaching in the new curriculum we weren't in the old and vice versa. We also had much clearer relationship between courses because we specified what they should be. We designed the courses, all the faculty understood what they were. Those will of course fade over time. Each course also had a clear story. We found that one of the things that happened as courses maintained individually is they lost their unifying concept. And now we had courses that had a unifying concept. We could say, this is the course where you start with electrons and end up with C, or whatever it was, right? We could summarize each course in a sentence, which helped to have a sense of flow, help students understand why particular topics were part of the course. We also had a faculty member that liked to talk about our courses in terms of vegetables versus candy. And some of the courses you're doing candy, it's a lot of fun, but it's not going to make the student a better person. And others are the vegetables that they generally don't like to eat, but they're making them better. And we found this is a useful thing to think about, that contextualizing the vegetables, helping the students understand why this thing that they weren't intrinsically interested in, but we all knew was important, was actually important. With better contextualization, they were happy. They understood what it was for. And there was the emotional reward of a sense of unity, accomplishment, revitalization. We spent a decade working together and it worked. Hooray, aren't we amazing? That is my talk. Questions? Yeah, that varied over the course of this. We were growing rapidly while designing. So when we started this program, we were about 4% of the university. So that was we were graduating about 250 students a semester. By the end, we were graduating, not a semester, a year. By the end, we were graduating about 600 to 700.
So how would that, would it make, I assume it would be easier in a much smaller department than that.
That's an interesting question. Would it be easier in a much smaller department? There are fewer people. So fewer people to get ideas from, fewer people to make sure they understand things. Probably all of the steps could be faster, because you'd have fewer people to talk to, fewer ideas to integrate. I mean, in the end, you're still teaching as many topics. The curriculum itself will be as complicated.
It's not a question, it's just a comment. When I hear you talking about the cost of doing this, regardless of the currency, like you say, happiness of the faculty, the happiness of the students, or the quality of the product that we are producing, how many alumni are in key positions in the industry or whatever. Like, I think it's important to think also about the cost of not doing it. Just that's my comment. Yeah,
what is the cost of not doing this? So I mentioned I don't know very many people that have done this, or at least published that they did it. Most courses, most programs I know of, built a curriculum sometime between the 60s and 90s, and they've just changed individual courses or maybe pairs of courses since. You can do that. We have many examples that you can create well-ranked, respected programs that way. But I think you end up with, in general, bad fit, right? And you end up with things where students are expected to know something they were never taught, and things where students are taught things they already know. And broadly speaking, there's a cost of stress and wasted time that I think is the result of a curriculum that is aged.
We do have some students in the audience. Would you guys say that you have experienced those two things in your studies here?
Would they tell the instructors?
Other questions? I'm just want to get you out. Okay,
I'm just kind of curious from a student perspective. Like, to me, 8 years is, that doesn't matter to me. Like, it's not going to help me what you did 8 years ago.
Yeah.
How do you like show that to the students that it is going to matter to them, even if, like, the pilot students, if it's going to like actually impact them, and how they can be doing their part?
Great question.
To me, it's kind of to me, I'm like, I don't care. I want to get out. Let me finish.
That's right. That's right. Yeah. So an excellent point, right? And even if it took a year, even if it took an instant, if I started new freshmen on the new curriculum today, what benefit would that have for you? Well, none, right? You're on the old curriculum. So what's the point? Well, okay, there are several points. First, I mentioned all these things we learned about our courses along the way. Many of those we fixed in the old courses, right? When we learned, for example, that there was an assignment that many people were doing when they got so much stress they blew up, we went to the instructor and said, by the way, while designing the new curriculum, we found that this assignment in this course is a problem, fix it. And they did, right? So the introspection resulted in immediate gains, and made our old curriculum better as well as our new curriculum. So there's certainly that benefit. There's also a longer term picture. there are two broad things you get out of an education. One is an education. The other one is a piece of paper that associates your name with a particular university. The better that university gets in the future, the more worth that paper is to you, right? So if somehow this school becomes a better school 10 years from now, your net worth goes up, right? It may not immediately cause a pay bump, but you're going to become better respected, able to get things. So from a purely selfish standpoint, I can think of at least two reasons why you should be excited about this happening.
It seems like a lot of the success of this, I mean, there's probably a whole dimension to also the maintenance of the quality of the curriculum to make sure it doesn't degrade after you put all of this work into.
Yep.
Right. But I would assume a lot of the success of this depends on explicitly designed feedback mechanisms, you know, where you're collecting information about the effectiveness of things. And so I just wondered if you have documented anywhere or could quickly summarize, and you've mentioned it briefly throughout the talk, but the types of feedback mechanisms that you explicitly designed to gather information about student outcomes, you know, pleasing industry, da 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 da.
Yeah, okay. So a lot of this I characterized in our requirement solicitation. First, let me say, broadly speaking, I work primarily with Mark Sheriff on this. I think he's more optimistic about the maintainability of a curriculum than I am. I believe that we can slow down its aging, but it will age. Like, you can make maintainable software, but eventually it will get brittle, is my general attitude. But I do think we can slow that down. I think we make it go better along the way. So what are we doing? There is a new curriculum that comes out every 10 years. We established a practice and expectation amongst our faculty that it will come out, and then we will spend a year inventorying all of our classes, comparing it to curriculum, and presenting a report to the faculty. So there's another one due in, actually it was originally due this year, but I think it might be coming out next year maybe. We'll see how that goes. And I'm sure when that happens, UVA will jump right back on that, review the curriculum and see where they stand, okay? The activity we did with the teaching assistants turns out to be hugely valuable. We learned all kinds of weird things by asking our students how they would change our courses. Usually not directly, usually indirectly, when they would say something about, we need to cut this class in half. We need a new course on that. Often this taught us things about how things aren't fitting together well. And so we established this pipeline of asking that every year. We're still asking, even though we've rolled out new curriculum, or at least I assume they are. I'm not there anymore, but they were when I left. And then we take that feedback and we go back to the faculty and say, hey, here's a thing you should think about. And then visiting with the faculty individually, I don't know if they'll keep doing, but there's some sense here. My expectation is for the next decade or so, the faculty that were a part of this will remember they were a part of it. They'll understand the curriculum committee is responsive to changes. They'll bring up problems, and there will be sort of a more active kind of maintenance. My expectation is that as more and more of the faculty have been hired after the change, they won't remember there was a change, they won't realize things can change, and things will start getting brittle again. I also commented, so I had this comment here, where was it? Our department head very, very much wanted us to have full and detailed specifications of every course. We found this to be basically impossible. So we had one course in particular where we spent a fair amount of effort making a detailed specification. We ended up with a 6-page document describing what the course should do. We got all the faculty that taught the course to agree. And then literally the next semester, we had students complaining that their section was worse than the other section, and they were being disadvantaged because they were being taught less stuff. We went back to the faculty and found they were teaching almost nothing alike because they interpreted the document differently, right? Can we specify them so they stay put? I'm pessimistic. We tried many times. I don't think you can. I think this has to be an active inspection. I think it's part of what ABET in its accreditation system is trying to get out of this continual program evaluation. I think many departments, I don't know about yours, but many departments I've talked to seem to do this as sort of, let me find a way of checking the box. I will do the bare minimum I think ABET will accept. And I think we learned there's a lot of value in doing a lot more than that, of checking you know, if you get a C in this course, what's the grade distribution in the next course? How does that compare to other pairs of courses? If there's something going wrong, the more we collected information, the more we understood how to identify problems early.
Got one question from our online audience here. Actually, a two-part question. First part is, what percentage of your faculty was knowledgeable of CS education and pedagogy research already?
Okay, so our faculty almost doubled during this time period. Let me think. I would put it in the, depending on how generous you are in the definition of knowledgeable about this, between 5 and 20%.
All right. And the second part is, what can you share about getting faculty prepared and on board?
Prepared and on board. All right. Faculty are really good at their jobs, right? If faculty know what they're supposed to teach, they'll generally find a good way of teaching it. Now, I realize some students will disagree. When I was a student, I would disagree, right? There's a lot of comparing faculty, and they always have something they do poorly that stands out and makes us forget everything else. So what do they need? They need to really understand why we were doing this, and anything that was outside of their comfort or specialty, they needed details on. So I mentioned that we integrated sort of ethical and social issues. We found the number of our faculty that were comfortable having a conversation with the students about intellectual property law was too small to do it. So we got the ones that were to write detailed lesson plans of the form. After you do this activity, come into class and ask the students this question. You will get this set of responses. Here is how you can respond to each of those. After you've had a conversation, this is the next thing, right? Planned out to the level you would more commonly see in like a high school curriculum where people are teaching all day and don't have time to think for 3 hours about every hour lecture. So some content needed that level of agreement. But mostly we just needed to make sure they really understood what can you assume students know in advance and what are you intended to produce. Some faculty, mostly our older faculty, but not only, also really wanted us to say, this course basically follows this textbook. The teaching out of textbooks is decreasing in popularity in our field, but many of our faculty still find that, even if they're never going to refer the students to the textbook, to be a very good way of categorizing what the course contains. That wasn't in our first set of designs. So there are courses we designed them, and then somebody said, but there's no textbook that does this, and we frantically scrambled around until we found one.
You talked a lot about like the way like material moved around and like changing some assignments for
Yeah.
classes, but I think like, what ways did you guys like review the like how courses like the students' assessment when you were looking at things? Because I think that's the problem. I've kind of felt as a student like kind of excited about learning about the course, but then as the semester kind of goes on, get kind of lazy and tired and just figure out what the minimum amount of work I need to do to get an A.
Yeah. All right. I heard two different questions here. I'm not sure you asked both of them, but there was a question about student assessment, which I first interpreted to mean the formal assessment at the end of the semester, but then also what do the students think of the courses? These incidentally are different. One of the more interesting exercises I ever did was volunteering my time as an experienced faculty member to read student assessments with new faculty to help them contextualize comments. Formal student assessment do something, but not a great deal. But there's this informal student assessment of sort of like, hey, were you still excited halfway through? That's a complicated thing. Has a lot to do with how things are taught rather than what's being taught. There's some impact on what's being taught. We've had a lot more to do with the energy level of the instructor, of the pacing of the course, of the assistance that was there, had a lot more to do with students' energy sustaining through the course. That's not really something we decide at the curriculum level. So there is a separate and interesting talk about how do we help faculty learn to teach courses that keep students interested. the closest we got there is we found that a characteristic of courses students liked was that there was a consistent story that explained the parts that they didn't want, right? Almost every course has some content you are not intrinsically interested in. This is a nature of courses, because some things I have to teach not because they're interesting now, but because they'll enable something interesting later. And the farther that later is, the less likely it is to be a pleasant experience, right? And so how do you help students get that scenario where they're dealing with the hard part, the unpleasant part for them, which may vary from student, and stick with it? And we found having a story that we're telling, a narrative that can be understood without yet understanding the material, was a very important part of doing this. And so each of our courses, we came down and said, this is the purpose of this course, right? Here is the course where we teach you why we call it information, why information is the word of the age, right? This is a course about information. And that is a story that we can come back to when you get to some part of, you know, talking about red-black trees versus AVL trees, and you're like, why am I doing this? If that's the one that you think why you're doing this, some people love it, right? Then knowing that that's the story both gives an opportunity for the students to understand things, and also gives a context for the faculty member to answer those questions about why are we doing it. Saying, here is this thing's role in a bigger picture. Yeah, I don't know if that fully answers your question. Did it answer your question? Would you like a follow-up?
That was good enough, I think.
Okay.
When you were developing your new curriculum, how much did the traditional aspects of computer science, what's been taught for 40 years, how did that play into with the older faculty accepting the new curriculum and saying, well, this still needs to be taught, even though maybe it is old tradition? And so how did you balance that with the newer faculty versus the older faculty and the changing and that kind of?
I'll get to this question. Let me first tell you a slightly related thing. In our paper, you'll find there is a weird, there's an aside about the importance of terminology. At one point, we were calling our new required courses the new core. And we found out that faculty were really upset with that terminology. Not all of our faculty, but some of them just didn't like us calling it the core, because they believed that whatever their topic of interest was core CS, right? And we said, okay, so everything can't be core. And they said, no, mine is core, right? That isn't quite how they worded it, and it got a little messy. And we realized that what we needed to describe instead was the foundation. And the foundation was the stuff other stuff built off of. And that was what we ended up calling our new set of required courses, was the new foundation. And that change in perspective also helped with this other question. There are things that are traditional CS that we didn't build off of. We weren't using anywhere, right? Why were we teaching it? We were teaching it because of a sense that it was the tradition. Some of that sense of tradition, the consensus of the faculty overall, was a tradition that's important effectively as a shibboleth, as a thing that you can talk about intelligently to signal you are part of the educated computer science community. Some of that, most of our faculty genuinely believed really mattered. It was sort of a leaf outcome of our courses. But some of it just didn't matter, except to a few faculty. But once we had the lens of what depends on this, then we could decide where it goes. So for example, every algorithm course we could find, every algorithm textbook we looked at had a whole section of max-flow min-cut problems. And most of our faculty thought max-flow min-cut was important, but nothing we could find depended on it. We had a few graduate courses that used it, but nothing else. So it moved out of the foundation, right? And even though most of our faculty thought it's important, we kept it in a required course, but a required course that was sort of a required leaf course for just some of our majors. So that criteria of what depends on it, we found to be a very useful way of dealing with separating the notion of tradition versus importance.
So I'm assuming you did some of this analysis with your the other courses from other departments, colleges, et cetera. So I'm specifically interested in math. What did you end up with thinking that this math was really foundational?
Yeah, math was a contentious subject. We learned weird things about math. When we made a list of topics taught in math that were used in our courses, it was not a large list. Logarithms, we had a couple courses that need derivatives, and we needed a little linear algebra and a tiny bit of probability. And except for some electives that we could give special math prereqs, that was it. And yet we also found fairly compelling evidence, much of which has been published by others. We didn't feel a need to publish our consensus agreement, that having had more math courses improved your ability to perform in our degree program. We're like, well, that's weird. Why would taking Calc 3, which we literally never reference except in one elective, why would that improve your GPA in our course? It seems to. We can look at the numbers. There it is. Why? It's hard to answer why scientifically, but our general opinion was that there were side effects taught along the way in math that wasn't math that we depended on. The one we primarily noticed was the idea of solving word problems. In CS, we tend to give a lot of, here is a paragraph or page or 10 pages describing a problem, write code to solve it, right? And where do you learn this thing, this practice of taking text, a story, and turning it into something formal? Well, you learn it in math, right? And the more math you take, the more of it you've done. We're not sure that's what was going on. We don't know how to even test that that's what was going on, but that was our gut. So we ended up with some disagreements amongst our faculty about how much we should require these courses where we're not using their topics, yet taking the course still helps you. And we ended up effectively with each degree program made their own decision. So our courses require Calc 1 because we had courses that needed them to be able to take derivatives. And then some degree programs and some electives had additional math requirements. I think broadly speaking, we had a consensus that there was a more complicated idea than we wanted consensus on. And so we compromised.
All right, I think that wraps up our question time. So again, we will have some light refreshments out in the atrium after the talk. Luther will be out there with us, and you have a chance to potentially talk to him one-on-one if you'd like. And at this point, let's go ahead and thank Luther for coming down and sharing his knowledge with us.